second way to draw it, which is for part B. And looking at what most people drew, it looks like we went for B first. So I'm going to do the B part first. So we have two wires, one at 53.1 degrees and one at 67.4. So let's draw that. Here's the telephone pole. This one is at, the first one is at what angle? 53.3? And the length of the wire is 15 meters. And there's a second wire, and its length is only 13. And so the angle is bigger, it's 67.4.
I drew it like
Which way? The first
way.
No. It's okay this way now?
Yeah.
Yes? Now, can we get this angle here? Of course we can. Let's get it. So 180 minus 53.1 minus 67.4. So this one is 59.5 degrees. We can use the cosine rule to get this x here. Yeah? So we can say x squared equals 15 squared plus 13 squared minus twice 15, 13 cos 59.5. So we get x equals 27.87 meters for the x. No. Oh, you know what? I left my calculator in radian mode from the last class. So putting it back into degrees mode. 14 meters. That's part B actually of the question.
So we're trying to find the minimum, right?
Yeah, the minimum now. So there's another way you could have drawn this that would have been consistent with the story. You could have had the telephone pole here, and the first wire again is still 15 meters and 53.1. But I never said in the question the wires are on the same side or the opposite side. So I could have had the both wires on the same side.
So I did it correct the first time, technically, because I was doing it for A.
Did you draw two wires?
Yeah.
Oh, I didn't see that. Yeah. So that's the first part then.
Yeah.
What angle is this? 67.4.
How come it has a bigger angle?
Hmm.
I'm a little confused that part.
It's shorter wire closer to the pole.
Shorter means bigger angle.
It has to look up steeper because it's closer to the pole.
Okay.
What one is this? This is 13 meters. So let's calculate this angle by first calculating this angle. 180 minus 67.4, 112.6. 180 minus 53.1 minus 112.6. This angle here is 14.3.
Why?
What do you mean, why?
Sorry, I just wanted to ask you this before because I don't know how to calculate angle.
This is 67.4.
Yeah.
The total here must be 180. So 180 minus 67.4 is 112.6. And the three angles here must add to make...
Got it.
Right, so we'll call this distance now x. And again we use the cosine rule. X squared equals 15 squared plus 13 squared minus twice 15, 13 cos 14.3. So you realize what's the only thing that's different? It's only the cos, isn't it? So if I just back on my calculator and change the angle, I get x is 4.01 meters. Not 5. Huh?
It's confusing because
Yeah.
I told you the ones at the end were hard. Yeah.
in the exam,
Oh, in the exam I'll give you the diagram. But this is an important example. It has a name. This type of cosine problem is called the ambiguous example. And it's called the ambiguous example because ambiguous means not clear. And there's actually two ways you could have drawn this. And both ways are consistent with the information given. So you have two possibilities here. Yeah. So this is the ambiguous case then. If I didn't draw the diagram, what are you asking me? Yeah, really, technically both answers here are right because the question never said if the wires were on the same side or opposite side. So technically there's two answers here. They could have been 14 meters apart or 4 meters apart. But such a question would be too difficult in the exam as it is. In the exam they would likely give you both diagrams as an A and a B part of the question and ask you to find the X in both cases. Yeah. This was a hard one, I know. That's why I knew I wanted to do this one. And the next one's a bit hard as well. Next one was very hard. Did you get an answer? Was it right? Was it? Yes, actually. This looks like the right way to do it. How long did that take you?
I said this.
30 minutes? Yeah. It's a long one. You got it, and it was a very hard question. Let's have a look at it now. Again, I just want you to try and first draw it. But a little bit of a hint I'll give you is that you should draw it looking from the top and looking at it from the side. Okay, so there's actually two diagrams here. See if you can just draw it here. Okay, let me draw it now. So, looking at it from the top, here's A, here's B, and here's C. How far apart are A and B? And B and C? 17? And then A and C, we don't know, that's what we want. Now, if I look at the side in 3 dimensions, that's not quite right, but we'll have to do. This is A here, this is B here, and this is C here. This, of course, is 19, this is 17, and this is X. And there's a helicopter directly above them, and they're each holding it in place with a rope. How long is the rope? 20... Each 26 is the rope.
Yeah, exactly. I thought they were flying.
I thought they were on the ground.
I thought they were flying in the first.
It's superheroes.
Yep.
No, all superheroes fly.
They do.
Does Batman fly? No.
Yeah.
He has the ability for flying.
That's what he does.
Yeah. Exactly.
But everyone with super strength flies. Batman is good. Only human.
Does the Hulk fly?
But he is
No.
He jumps.
Okay, I give up.
It's not the same though. Right, so the rope's 26 meters long for each of them. And the helicopter is at a height above the ground of 24 meters. So what I need you to see in this diagram, the only thing I need you to see in this diagram is the fact that I can draw a line on the ground and make a triangle here with the first person. I can do it with the B person as well. Can you see what's happening? And then I can do it with the C person here. I can make a triangle. I can make 3 right-angled triangles.
Oh my god.
Can you see that? So if I look at the first triangle that goes from person A, how long is their rope? 26. And the height? 24. And if I look at B, how long is their rope? 26. And the height? 24. And then the C person, 26 and 24. So you can use Pythagoras to get the base. It's 10. But what do you discover? That they're all 10. So all of these lines on the ground are 10. Yeah. So if I look now from the top, I have a line here to the helicopter, which is 10. Here to here, 10, and here to here. These are the ropes now. 10. So all of these are 10. 10, 10, and 10. And that's it. That's enough now to work it out.
Yeah, the theorem.
Yeah, what we can do, here we have 10, 10, and 19. So we can use cosine rule to get this angle, which I'll just call it A. And then here we have 10, 10, and 17. So I can use it to get this angle. So for example, I can say 19 squared equals 10 squared plus 10 squared minus twice 10 by 10 cos A. So this gives me A equals, let's calculate it. I'll double check it. 19 squared minus... So the angle here is 143.6 for the A. Now, what's the only difference in the B example? Except there's one number that's different though. The 17 instead of 19. So if I just go back on my calculator and change the 19 to a 17 and recalculate, I'll get the B is equal to 116.4 degrees.
What?
I just recalculated this, but the only thing that's different is the 19 is now 17.
Yeah.
So if I know these two angles, can I know this angle?
Yeah.
Yeah, so that angle, I'll just call it C. It's not really C, but I'll call it C. That's going to be 100. How did I get 100 now?
That plus that and then minus 300.
Yeah, that's it. 360 minus these two make 100. So now I can say x squared equals 10 squared plus 10 squared minus twice 10, 10 cos 100. And I get to the nearest meter 15 meters. That was a hard one, but the difficulty in it is the picture, not the calculations. Because actually when you look at the board, you realise there's not actually a lot of calculations there.
But how do we calculate the pictures? I mean, how do we draw them in the exam?
Imagination. No, in the exam they'll give you the diagrams.
So, yeah. So why making it by touching it?
Some of the questions I gave you the diagrams, but to make the ones at the end a little bit harder, I took out the picture, because it's important to be able to visualise.
It's never going to be in the exam.
They've always given you the diagram in the past, but there's no rule in the syllabus that says they are guaranteed to give you the diagram. So I'm covering your bases, you know. They have in the past, but there's no rule that says they must give you the diagram, you know. So it's just about covering bases.
Insurance.
Yes, insurance. Okay. What else is on this practical one? Let me just see. Anybody get number 9? No? I would like people just to draw 9 again, and then I'll do it. Right, let's have a look at this. And then I just want to put a little hint in for the last one. Right, a plane leaves point X, another plane leaves at the same time, another plane at the same time leaves Y at the same speed. Y is west 20 degrees south of X. So here is point X, and Y is, what did I say, west 20 south. North, south, east, west, west 20 to the south. So Y is here, and this angle, let me put in my compass, this is east-west, and then this is north-south. So this angle here is 20 degrees. Okay. So what did I tell you about X? Oh, I didn't actually say, I'm sorry, I left out about the X. But I'll tell you what the X is doing now. What I didn't say here is where X is heading. So I'll tell you now, and now you can try it. X is heading east. So the plane here that leaves X is heading to the east. So I'll just add that in. A plane leaves point X heading east. Okay. So my question is, at what angle should Y fly at so that it can meet the X? Have a think about that. You know what? I think that this is way too difficult for you. Maybe I'll delete it. Anybody feel like they could get an answer? You want to see it before it's gone forever?
No,
Maybe I'll make it a little bit easier for you by giving you more numbers. And I'll change the angles a little bit too. So,
solvable?
no, it is solvable, but I'll make it a little bit easier for you. So I'll say the plane leaves here, and I'll give you a speed. I'll say 100 kilometers per hour, and then I'll put it to the right. It'll be a little bit easier as well. And we'll make the angles here, I'll just call this angle 30 degrees. And to make it clear, I'm asking you, what angle does this fly at? So I'll call the angle here alpha. And I want it so that the two of them will meet later, and we'll make the speed 100 kilometers per hour as well. Okay. Does that make anything any better?
Yeah.
We have some numbers now.
Numbers make people feel better, yes, okay. Did you say no?
That's all. I hear stuff I don't understand. That makes me scared.
Well, everything's clear on the diagram now. Yeah. Okay, let's have a look at it now. Did you get an answer? Get an answer? You'll be disappointed when you see it, I promise. You will be, when you see how it's done, you'll be disappointed.
Are you
Okay.
gonna edit it at home? I mean, like,
I'm going to rechange, I'm either going to delete it or replace it.
there.
Let's have a look. Right, so, after 1 hour, how far has this plane travelled? 100. After 2 hours? 200, sorry. After 1 hour, this one? 100, and after 2 hours? 200. So after 1 hour, they've both travelled the same distance. After 2 hours, still the same. So when they meet later, there's one thing you know about how far they've each travelled. They've travelled the same distance. Now you don't know when they meet, do they? No, so you don't know how far they've travelled, but at least you know they've travelled the same distance. So what type of triangle is this? Isosceles. So this angle is the same as this. But what's this angle? 60. And this is 90. And what's this angle? 60. Yeah, and this angle is the same as this, so this one here is 60. And all of this, so this one here has to be 60.
That's it.
Told you you'd be disappointed. I can feel your disappointment.
You're feeling
The
it.
problem is, the answer is considered like,
Yeah, but I might have changed I changed this one a little bit to make it easier. So I'm going to edit the easier. I'm going to edit the question, and maybe I'll put in a hint that says, think about how far they've travelled when they meet. Well, if I told you that they both travel the same distance when they meet, would that have made you realise that this is isosceles or not?
No, I mean,
No.
it's the same thing. I mean, with a toughness, yes, so it's the same thing now. I don't think.
But anyways, this is okay now that you saw it. Yeah. Okay, so I think we'll have a look at, well, do you want to have a look at equations of graph, or do you want to do a bit more practical? Because there's still one practical question left. So do you want to see that, or do you want to move on to equations and graphs?
Did you release more practical problems online?
Well, the past exams are online, and they have practical problems in them, so you could practice with those ones. And I think also there's a maths book online that might have more questions in it. The Pure Maths C1 and C2 is online as well. Do you know this book? It's on.
I'll check.
Yeah,
Oh, yeah.
it's on the Moodle page. Yeah. Anyways, what do we think? Do we want the last one, or want the last one? Yeah. For those people who don't know, I'll draw it, and then you can try for a minute. So, what is the radius of the biggest circle that can be put into a triangle with sides 13, 14, 15? So, what we have is a triangle. This side is 13. This side is 14. This side is 15. and we put in here the circle, the biggest circle we can put in there. And this is called, I said in the question, incenter. Yeah.
So in center is the definition.
Does anyone know what incenter means?
I didn't think it.
No. No. Incenter is the name of this circle, the biggest circle that you can put into it. But what's special about this is that if you were to draw a line, now maybe once I do it you might remember seeing it in middle school, not middle school, it's more high school. If I draw a line from here out that cuts this angle in half, and I draw a line from here out that cuts this angle in half, and then I draw a line out, oops, yeah, here, that cuts this one in half, so these are the same. This will be the center of the circle. You might have done it in construction, yeah. So in construction, what you would have done, if I just go back a second with your compass, is it? Yeah. If you've done this in construction, you remember if you put your compass here, and then what you do, you mark off, you mark off this, and then you mark off here, and draw a line through it. Yes. Yes. You remember this? You did this one? Yeah. So anyways, here to here, here and here, these angles are the same, so, and these ones are the same, and these ones are the same. It splits the angle in half. So if you knew this angle, and you divide it by 2, you have this angle. And if you knew this angle, and divided by 2, you would have this angle. If you have this angle and this angle, can you have this angle?
Yeah.
And if you have these 3 angles and this base, well, what more could you need? You can get the height here, and the height is what you want because the height here is the radius. Yeah. So you know, I think now I'm going to leave this for you to try at home. Now that you have this insight into it. So my hint is get these angles. What rule will give you these angles? Cosine rule. And then what do you do with the angles? To get these ones? Divided by 2. And then you can make a triangle here. Yeah?
But the problem was, after drawing those triangles, how would I know the length?
Well, what you could do this. You know this angle, yeah? And you know this angle, and you know this angle, and you know this side. So using the cosine rule, you could get this side, and you could get this side, right? Then, what you want, if you wanted to, could you get the area of this triangle? If you know this side and this side and this angle, yeah. And then you could say half the base by the height then.
Well, I did not find the half angle.
If you didn't know about the half angles,
I did not divide by 2.
you're not going to get it. So this was the key here. You know, that reminds me, there was one question in the area worksheet that I should do.
Yeah.
The one with the triangles stacked on each
Oh,
other.
that's easy.
It worked out okay. I don't need to do it. Oh, fantastic.
There's
All
another
right.
area that we need to have.
In that one?
I think.
Yeah, okay, let's have a look at it.
The one
We'll do equations, don't worry.
on that one.
We'll do it.
No, half an hour.
Come on, I'm in. Goodness sake. Calm down yourself. Could say the same thing to you. Alright.
You're excited? Okay.
Do you drink coffee?
No, I had bacon.
This doesn't usually energize people so much.
Olive oil. With the bacon.
Weird. Right.
Yeah.
Oh no, I redid the worksheet, so it's now called Area 2, is it? Wait, what am I looking for? It's in the area worksheet, isn't it?
Yeah.
Oh yeah, here it is, Area Trig, that was it, sorry. Which one were you thinking of now that you want to see? So this one was nice,
Yeah.
So which one then?
I guess,
No guessing, which one? You should remember it.
8, 9, I was able to solve it, but I didn't use the area, so I thought I did something wrong. If there was an exam, they gave me the area.
Okay.
And 10. No, not 10. 11. I think, let me check. It was definitely 8. 8 was on it.
Yeah, which do you definitely want to see?
Yeah, 8, 9.
The trigonometry equations. Don't worry, I'll definitely those. Do you have ones in mind? So,
8.
okay. Did you do all this? No, we didn't do it. No.
We did the first 4. 8, 9.
Wait, okay, fine. While you have a think about which ones you want to see, I'll do the trig equation then.
No, it's right here.
Fine. Okay, well then I'll do those ones then. Right, now, trig equations. Let's see.
Sine, cosine, 10.
I mean, I've no patience left for you today, I'm sorry. So, for the rest of the class you need to be good, okay?
Yeah.
Now, let's see. I can't... Sine, cosine, graphs, area. There it is, equations. Okay. Was there one you had in mind? Number 1 is very important for the exam, so I'll look at that. Yeah, what I did with the other students was Q and OR. So, will we do that together, Q and OR then? Okay. So, can we all have a look at Q here? Here it is here. Right, so let's have a look at this together now. Just read it out to me, if I can switch to the notepad. Did you write it down?
No.
Yeah.
I did. Number 1, right?
Yes, 1Q.
1Q. Q is 2.
Wait. I'm giving everyone a chance to write this down from the board. You have this?
Yes.
Okay. So, it is 2
cosine squared.
Hang on, sorry. 2 cos squared 2x.
Minus 3 cosine 2x. Plus 1. Given by 0.
0 to 2 pi. Yeah.
No, not pi.
Not
0 to 360.
the 360, it's in degrees, is it?
Yeah.
Yeah, okay. So, what type of equation is this? The quadratic. So we'll try and factorize it. This is going to have to be 2 cos 2x minus 1 and cos 2x minus 1. The factors, the roots have to be a half or 1. Now if you didn't know that, you can use the formula, the minus b, the quadratic formula. So that's fine. Is that okay so far? Now, here we can say 2x equals cos inverse a half. So if we hit in cos inverse a half, we'll get 60 degrees. How do I get the second answer? Yeah, 300. Here, cos inverse of 1, 0, and 360 minus 0. How many answers should there be for a 2x? And 4 here. How do I find the extra answers? Add 360. Yeah. So, yeah. I will later. Remember, the order is very important. I, E, F, F. So, after the extra answers becomes the simplifying. Right, so, yeah. Yeah, but again, the order, please, the order. The last step is where I fix the answers, okay? So please, I, E, S, F, I don't get the X until step 3, and I don't fix it until the last step. And again, I think I made it clear in class that it's very important to keep to this order. Okay. Now, this one here, how do I make the extra answers? I add 360. So this one becomes 420, and this one becomes 660, and this one becomes 360 and 720. Now I can get to the x. So how can I get to the x? I divide by 2. So I'll get 30, 150, 210, 330, 0, no, not 330, what am I saying? 330, no, sorry, 0, 180, 180, and then lastly, 360. Now we can fix. So, this is okay, and not okay. So, is it too big or too small? Too big. So I can minus 360 and it becomes 0. But that's already included in my answers, so I don't need to include it. Also, I have 180 twice, don't I?
Yeah.
So I don't need to include it. So really, it's just these that are the answers which I can use. 180 was already included, and 360 becomes 0, which is already included. So 1, 2, 3, 4. These are the 6 answers here. There's 6 answers. Yeah. We'll do the next one as well. Is that okay? Yeah. So what's throwing you off with these? Is it the order or the? Okay, but it's the same type. It's just a sign, and this is a cost.
I made a mistake because I forgot to do the order thing.
Yeah, cannot afford to do that. Weird. Yeah, all right. Let's have a look at the next one. What about the last one, the or? Can you write this down?
The or?
Did you get it? Good. Or. Okay, let's have a look at it. What's the equation, please? Minus 2x. Now, why is this not a quadratic? Yeah, it's not a quadratic in cos, because if it was a quadratic in cos, there should be a cos squared. And it's not a quadratic in sine, because if it's a quadratic in sine, there should be a sine. So we need to convert, and it's easy to convert sine squareds into cos squareds or vice versa, because last time I said we have this rule. Yeah. Cos squared plus sine squared equals 1. So that means sine squared equals 1 minus cos squared. So here I can change this into bracket 1 minus cos squared 2x minus 3 cos 2x plus 3 equals 0. Yeah? Yeah, minus 2 plus 2 cos squared 2x minus 3 cos 2x plus 3 equals 0. 2 cos squared 2x minus 3 cos 2x plus 1 equals 0. Looks familiar? It's now become the last question.
So all you did was convert the sign.
Yeah, but now everything else is the same. It's become the same equation as the last one. It's the same now as 1q.
What would you do this time?
What?
We don't have to waste our time on this one. Do that one.
Yeah, because I mean it's the same. It's the same.
This is a question. Maybe this
Which one?
I know this one we did in class. I'll ask you later.
Next week for today's topic. Yeah?
No, not today. This is the same topic over here. I don't think. I don't know. I'm not sure of it.
Which question?
This one in class we did an example.
What are you talking about? We didn't do trigonometry today.
No, but not today.
Oh,
No.
this one.
Yeah. You used this twice with me.
Use what choice?
Like you added 360 over here, then you added
Yeah, 'cause I need to
360.
make 4 answers.
So you could. Why didn't you add 360 from here?
No, you take a pair and add 360 to both to make another pair.
Yeah, but you didn't add 360 to this.
I'm sure I did.
No, I checked.
Yeah.
I was replying. So. add 360 to this.
Watch the video. Maybe it's either you wrote it down or I wrote it down wrong.
The video isn't online, so I'll check.
It's there now. It's there now.
Check it.
Yeah, they're all there now. Okay. Next, do we want to look at some area questions or some graph questions next?
Area.
You want area? Yeah. Yeah, because
I think the majority.
I'll do a quick graph one and then an area one. So let's open up a graph one. Graph one. We'll take something like.
Is that the tangent you do?
I've never seen tangent in the exam. I said to do a sine, a cos, and a tan example. How about I just do this sine one here, maybe? Yeah.
Tan is the hard one.
I did tan in the other class, the tutorial with the group 1, so if you wanted to watch the video you could see the tan one and that. But I think will we do this sine one here? Yeah. 2 sine x over 4, thank you. X over 4 minus pi minus 2. Start, end, min, max. Okay, starts at 0, goes to... Oh yeah, well before I do that, you can keep the table there, but before I do that, I'll just take out a quarter. Can you close the door actually? Thanks. I'll take out a quarter. So what will be left here? X minus what?
Pi. Or 18.
4 pi.
Oh.
Yeah. No, remember pi means multiply here, so we got it right by accident. Okay, so if I take the quarter out, I get this. Yeah? Right, so now let's do it. Start, end, min, and max. So it starts at 0, it ends at 2 pi, the minimum is minus 1 and the maximum is 1. What does the 2 do? Twice as big, vertically. What does the quarter do? Increase horizontally? How much? 4 times. So it would be 0 to 8 pi. What does this one do? Minus 4 pi? Moves it to the right, so now it'll be 4 pi to 12 pi. And then lastly, the minus 2 here. Down 2 units. So now this will be minus 4 and... Oh, sorry, I wrote a minus there. Sorry, minus 4 and 0. Let's draw. So, I have to go to 12 pi. So I'll make this 12 pi. So this will be 4 and 8. 4 and 8. 4 pi, 8 pi. Here, 2, 6, 10. And the height, it needs to go to 4, doesn't it? So I'll make this 4, and this one here 4. So this is 2, 2, 1 and 3, minus 2, 1 and 3. Right, where do I start? 4 pi. Where do I end? 12 pi. What's the highest point? Minus 2. And then the lowest? Minus 4. Then what's my next step? I break this into 4 quarters. So 1 goes here, and then 1 goes across here. And what graph is this, sine or cos? So it starts at the top, the middle, or the bottom? The middle. So this is what it looks like here. This is the graph. And if I quickly flick to the answers for part B, you can see that's what I get. No, which one am I doing? Was I doing B? Two sine, I better just like 2 sine x over 4 minus pi minus 2. Yeah, it was. Maybe I did something. Otherwise, my graph doesn't match up, so I've made a mistake. Oh yeah, it's me when I was drawing my box. The lowest is minus 4 and the highest is 0, not 2. Nobody noticed that, certainly not me. Right, so I'll just draw it again. Minus 4 and 0. Break it up into 4. Up, down, up. That's what it looks like. Ugly, but for exam purposes, okay. Yeah, so I just 0 is the top, minus 4 is the bottom, starts at 4 pi, finishes at 12 pi.
Can we do the area?
Let's have a look at how long it is. Area, which one?
9. Wait, yes, I won't make a mistake. Yeah, 8, 9, 11.
You have to pick one.
Well, which one do you think is the hardest?
Yeah, actually, that's more
Well,
important.
the algebraic progression, I know how to solve it, but I didn't use the area, so...
So, let's not do that one. What's the other choice? 8 or 11?
Yeah.
Yeah, let's just do 8. The area of a triangle with sides 13 and 15 is 24. What's the area of the missing side? I don't think that's too bad. So we have 13 and 15, and I tell you that the area is 24. So I want to know what's this side here. Yeah? So what formulas could I use? Well, I suppose I could get this angle, because we know a half 13, 15 sine theta, what should that equal? The area, which I tell you is 24, so 24 times 2 divided by 13 divided by 15, sine inverse. So I get theta is 14.25 degrees. Now, at the time, we didn't have the cosine rule. But now we do have the cosine rule, so it's much easier to do.
Should I reply?
Huh?
I mean, I should have, because I left this before we took the cosine.
Exactly. So now we can do it with... It's still possible to do without the cosine rule, it's just longer, but now that we have the cosine rule, we might as well use it. So we can say x squared equals 13 squared plus 15 squared minus twice 13, 15 cos 14.25 degrees. So 13 squared plus 15 squared minus twice 13, 15 cos 14.25 degrees. So you get 4 as the x. These might seem a bit easier now if you try them again, but remember, you now have the sine and cosine rule you can use to help you with your triangles. Very useful rules.
Yeah, I didn't have them at the time.
Yeah. Yeah, anything else? No. So I think that's a good bit of revision of the trigonometry chapter. In the tutorial next week, we'll look at the calculus that we'll be doing over the week. Okay? Differentiation is an important part of calculus, yes. Yes.